Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Thoriq Alfarizi, and my student number is 2206055265. And in this video, I'm going to to solve a problem that involves the numerical methods quiz given by Pak Dai. And in this time, I'm not only going to make another problem, but also I'm going to combine all that we have learned in this semester using Padai teachings. Okay, so we also in this problem have an optimizing problem. So I have the optimization part, and we also have the numerical method parts. Okay, so we have a problem here. And that problem is to optimize a portfolio using the mean variance optimization method. And I am given historical return data for three assets, A, B, and C. And my goal is to determine the optimal portfolio allocation that maximizes the Sharpe ratio. And what is the Sharpe ratio? That is the ratio of the portfolio's excess returns over the risk-free rate of its standard deviation using the mean variance optimization method. Okay, so let's solve this using the conscious thinking or the DAI5 method. And so the first one is intention. So we have a goal, and that goal is to find the portfolio allocation that maximizes the Sharpe ratio. And we have our criteria too, which is to maximize the Sharpe ratio, portfolio return exceed a specified risk-free rate, and we also have risk or standard deviation to minimize for a given return. And the final one is efficient frontier is calculated and analyzed. And we are going to calculate it using the Python code. And the second step is initial thinking. So we have our problem identification, and we have to understand the returns, risks, and correlations of the given assets, and to identify the risk-free rate, for example, 3% or 0.03 annualized. And the method selection is we choose the mean variance optimization for finding the optimal portfolio allocation. We also have to utilize the Sharpe ratio as the performance metric. And finally, use historical return data to estimate expected returns, variances, and covariances. So the third step is idealization, and we have to assume that the historical returns are indicative for future performance. We also have to assume that normally distributed returns, and we also have to assume that a risk-free rate of 3% or 0.03 annualized. And the modeling is we define the expected returns factor, mu, and we also define the covariance metric, sigma, and define the portfolio weights, such as this and this equals 1 and equals or more than 1. And we also have approximation and error tolerance, and it has set acceptable levels for the change in portfolio weights during optimization and define convergences criteria for the optimization algorithm. Okay, finally we have instructions, which has algorithm development, and it also has define inputs, compute expected returns, compute covariances matrix, and we define the optimization problem, and we optimize portfolio weights, and we check the constraints. And here is the implementation as a form of a Python code, and I already pasted to VS Code, and we are going to run the code. Okay, and as you can see here, we have already have the answer. to our code and we're going to copy it and paste it under here. Okay. After we ran the code, we can then execute and verify. We already run the code, we verify the answers, and we adjust the parameters. And I already make an example output, which is optimal portfolio weights equals A equals this, B equals this, and C equals this. And it matches our own solution, and we already verify it and adjust parameters. It's for um comparing from the past to comparing the past to the present solutions to maybe predict the future answers or the future solutions. And after that, we have our conclusions. So the conclusion is using the conscious thinking method to solve the optimization problem ensures a structured, thorough, and effective approach. This method enhances understanding, improves decision making, and leads to optimal solutions by systematically addressing each step from goal setting to implementation and verification. This reflective practice is invaluable for continuous improvement and deeper understanding of optimization in numerical methods. So that is my final video in numerical methods and in day 5 problem solving method. And I hope you enjoyed. Thank you, Padai, for teaching us, and maybe see you in the next time. Thank you.